Hello guys, in today's video I'd like to discuss about the isopreference curves. So what are these isopreference curves? These are basically used to illustrate the effects produced on image quantities by varying the n and k independently. So what is n and k? Well, n is the number of pixels that we can relate to the spatial resolution, and k is the number of bits associated with each pixel, so that we can associate it with the tonal resolution. So let us see what is isopreference curves. Okay, so what the scientists of that time did, they took these three images: one the image of a girl, second the image of cameraman, and third the image of a crowd. If you see deeply, the image of the crowd has lot of details. There are a lot of color shifts. Comparatively, if you see the image of cameraman, there is comparatively less detailing, there is less color shift, there is less sharpness. Comparatively, the image of a girl has very less detailing. So these three different photos were taken into consideration. What they did next was they took each of these image and changed the value of capital N and K. That is, changed the took the first picture, changed the value of N, changed the number of pixels, they reduced them, then they increased, changed the number of pixels, and then changed the number of K, that is the number of bits, and then showed it to many people. So this was basically a subjective study where these different results were shown to different people, and only those images that were better, that were in good quality, or that were good to the observer's view, that were plotted in a graph. So this is that graph. So what is basically done over here is, on the y-axis there is k, that is the number of bits. On the x-axis there is n, that is the number of pixels. So we had all these different images, the image of face, cameraman, and the crowd. And what the scientist had done was they had uh, varied the value of k and n for all the three images, and only those images which look good to the eye, which had a good quality subjectively according to the people that that was shown these images, they plotted the graph. So these lines are basically only the good quality images. So if you see, when there is a lot of detail, that is in the picture of the crowd, if you see the picture of the crowd, there was a lot of detail. So when there is a lot of detail, this line is almost vertical. This line is almost vertical. So this says that when the detailing is very high, you don't need to worry about k. That is, even if the value of k is 5, or even if the value of k is 4, the quality of image is more or less similar, so that does not matter. But what matters is the quality of n, number of pixels. You can see only n in this range has a good image. Also, if you see a cameraman or the face, you can see as the details reduce. Here you can see cameraman and the face photo. So as the details reduce, this curve goes to the right. So you can see if there is less detailing. If I speak about the face, so there is a less detailing. So over here you can see that if you reduce the value of k, see here the value of k was 5, so for this value 120 value of n would be okay, that would be a good image. Similarly, if I reduce the value of k further over here, so at this point I'll need to have the value of n greater. So here I guess the value of n might be say 190 or 300 one sorry 190 or 200, I'm sorry. So here, so this is the ISO preference curves, and this only tell you about what is the effects of changing the value of k and the value of n. Thank you so much.